Okay, chapter 4 is all about how to use derivatives, okay guys, to tell you about functions. Generally speaking, you will get the information about the derivative, which is the rate of change. It's going to be meters per second. It's going to be a ratio of things that change. They're never going to give you the function. We are going to practice with, well, I shouldn't say never. Most of the times they won't. But we are going to practice with some functions, and we're going to learn how to apply derivatives to tell us lots of things. The vocabulary is right up here, an absolute extreme. Extreme means maximum value or minimum value. So that's one of the words we have to know. Extreme value. A lot of vocabulary. Max or min. So when I'm looking at this, we'll just talk about these goals and as we look at it. What are extreme values? That's just the max or min. Right. My board's out of alignment. So we're going to talk about absolute and local, the difference there. And how do you find extreme values? And you did this in pre-calc, but you looked at your graph and you did it that way. We're going to use calculus to do this. And what are critical points? And the most important theorem here, this is on the free response. I don't think I've seen a year where it has not been on there. I'll give you the clues to look for it. It's always, you know, in a word problem, and you have to remember, oh yeah, it's that thing. I also call it the max-min existence theorem. I do both. Because in our old book, different books call it different things.
Where did you get this?
2000. No, this might be from older. I think it was 2008. Yeah. You're not going to like the homework. We don't like the homework if you did. So we may...
That is my number one question.
Excellent. Okay. So... Now, so extreme values are nothing more than the maximum, minimum values of the function, by the way. Whoops, there's back my pen. Okay, guys, when I talk about extreme values, it's the maximum, minimum value of the function. It's the y value. It's not the x value, it's the y. Okay, so when you take the exam, you need to read. As I'm learning when I graded your test, some of you had little problems reading. Read the questions, make sure you answer the question. Even as I'm sitting there grading papers at the reading, we're all sitting there going, why can't they just answer the question? You have the work, but they don't answer the question. So make sure you answer the question. So when we are doing extreme values, we are looking for the y coordinate. If they ask where, that's the x coordinate. Okay, is there a maximum value? By the way, when they say maximum, it's always the absolute. It's always the greatest one. So is there a maximum value of this function? It looks like right here. That is the absolute max. Oh, yeah, no. Is there a minimum value?
Yeah, -1. No. Oh, no.
If it's out of closed, if this is closed, if it's open, you're right, there isn't one. But if it's closed, that would be your minimum value. If it were like this, it goes up to that point but doesn't include it. This includes it. That's going to include it. Well, it's just my limitations with my pen. Minimum value. Now, there are other max and mins, but they're called local ones or relative. Oh, good. See, this one is in its neighborhood. Is in my neighborhood. You're looking just, you know, right next door. That is a local maximum. Even though this is the absolute max, it's also a local maximum. So you can be both an absolute and a local. This is a minimum in its neighborhood, right?
Yeah.
You could talk about the holiday lights. In certain neighborhoods, somebody's got the best lights. But if you wanted to compare everybody in the state of Minnesota. Then you don't have to say who's the absolute best. I don't know. But you look in the neighborhoods for just the local ones, right? I like local. They'll use relative, but that minimum. Now, this also could be considered a local minimum at that endpoint. We are not going to look at locals at the endpoints. You're not going to have to worry about it. I don't even want you to worry about it, but it can be a local minimum. My reason why I don't agree that it should be local is because you have to have, you know, I guess relative to the left side, it is definitely a min, but what happens on the right side? I just don't know. So if you want to think of it as one-sided, I suppose. And I used to teach that locals couldn't happen at endpoints, but I've been corrected by faculty, you know, PhD people that say, yes, they do occur at endpoints. And if you go on in math, you'll find an application for it someplace. But right now, don't worry about it. You just look in the neighborhood. And this would also be a minimum because compared to this one, it's a little bit smaller. But mostly I'm just worried about these. What's special about max and min in calculus? They're derivatives. What's true about the slopes of any of these lines? Of these, what is that? What about the slope here?
0, 0. Also 0, 0.
Well, that one's not zero because I don't know what happens on the other side. But the local ones, the interior ones, how about we say that? And we did that. Where does this occur? And you can find out where they occur. That would be this. That's the where. Okay, so where did they occur? They occurred at 2. So we have -4. Make sure you answer the question. Where's the next one? What is that? -2. It looks like the other one's at 2. Okay, how did we find it? What's true about the slope? Slope. What's another word for slope? Derivative. Which is dy dx, which is f prime, equals 0. So that's how you find them. Take your derivative, set it equal to 0, and you find where they are, but then you usually have to find out what the value is. Yes, I know, I said it, yours is more
What if
complete.
this is the function?
And that's the tough thing. You can always find local max and mins, maybe. What about this line? Does it have a local max and min? If I close these endpoints, then here's the maximum, and there's the minimum. What if I have this line, and there are no max and mins of any sort there? Because you can get really close here, but I can get closer yet, and I can't ever get there. So this has no max or min. What about another function that we all know and love? How about this one? Absolute value, right? Y equals the absolute value of x. Does it have a max or min? It has a minimum, that's right. What is true? There's my minimum. What is true about the derivative there? Excellent. F prime of x does not exist. So there are 2 places where you look for max and mins, local ones. You look for when the derivative is 0. So there's 2 locations for local, max mins. F prime equals 0, or F prime does not exist. That doesn't mean it doesn't exist on the function. Maybe it has. So that's not too bad. That's what you're going to do. You're going to find derivatives, and you're going to say is there a maximum and minimum there. What has to be true about your slopes? When you say the derivative is 0, I'm going to draw a function here where the derivative is 0 at this point here, but the derivative is 0 right there. right? Is that a max or min? No, it's neither. Okay? What has to be true about the slopes of the tangent lines for you to have a max or min? Go back, I'll just draw it here. It has to change sign. And it actually, really, for 1 through 4, 3 are just kind of all mixed up, especially in this book. So F prime, and, well, it doesn't, being 0 or not, doesn't matter, but it has to change sign. That's really what you have to do. Okay. Then there's, well, let's go on to the next page. So, now, in terms of my function, if I have a maximum value of at C, then all it's saying is that the y value at C has to be greater than all the other y values. Yeah, I want to put that way. Does that make sense? This y coordinate's got to be bigger than all the other ones. What about minimum? The y value, f of c, has to be, this y value is smaller, right? And extreme values, not sure what I was saying, but that's going to be f of c. It's the y coordinate. Locals too, within that neighborhood now. So let's make this. Okay, so in this neighborhood, this y value is not the biggest one. If you want the biggest one, it's the biggest y value of all. But within this neighborhood, this f of c is bigger than all the guys next to it. You can think of expensive houses, you can think of it that way too. Okay, so you guys kind of know all this from pre-calc. The difference is we're not going to do that. We're not going to look at the graph. It is not allowed on the exam. They did put one of these problems on the graphing calculator part of the exam, and my students graphed. And it's fine, you know, it's a great answer, except that didn't earn any points. You have to show the calculus. Yep. A is just saying that this y coordinate at C, so here's my C, this y coordinate is bigger than all the other ones. Pardon? And absolute. This is absolute, it's also local. This is local. This is the absolute. So this f of c is bigger than all of them. Absolute is just the biggest one. Or the smallest. If I min or max, doesn't really matter. It's just bigger than these. We're never going to really look at that. It's just a formality. Now, I would like to guarantee that I have an absolute maximum. Because I could have this. Let's see if we can make it an open circle here. Oh, I didn't want to do that. Yeah. Well, this works. I want to guarantee, though. So I'll close this one, and let's actually make this one a little, we'll just leave it like that. This has an absolute minimum right there, but does it have an absolute maximum? No. Right. And I won't even look at the endpoints for locals, because we will never be doing that. But you can, yes, you're right, there's a local one there. I want to guarantee that I have an absolute maximum minimum. So can you have a break in the graph? No. And also, if I do this, I'll do a little parabola. It has an absolute minimum, but does it have an absolute maximum? There's no holes in here. I want to guarantee an absolute maximum. You have to have what? Still can't hear the last. Both what? I would like to guarantee it. You haven't, because that's what's going to happen on the exam. This is an absolute minimum, but is there an absolute max? No. What's wrong with this one? Well, what could I do to fix this? What if I filled these in? Then would I have an absolute max? Oh, but I have two locations. I'm glad you said that. But what's the value? How many values? It's the same. I have two locations. It occurs twice, but they're the same. That's okay. You can have the same one. Mm-hmm. And we'll have a worksheet on that. In fact, just remember that worksheet. Okay, so what do you have to have? Don't do that. I don't know what I said. What are conditions you have to have? Can you have any breaks in the graph? What's the word to say no breaks in the graph? Okay, f of x must be continuous. And what else do you have to have? Remember, I closed these. I had open. Doesn't work if they're open. What's true about your interval? The interval has to be closed. What's going to happen on the exam is when you read between the lines, you're saying, oh, they want a maximum value, and they gave me a closed interval. And this is the theorem you're going to forget, but this is the one I have to remember. Because this is the theorem we're going to use. It's called the max-min existence theorem. I cannot get that to go away. There it goes. Those are going to be the requirements. Those are going to be the two requirements. And so then you're going to say, oh, I want to do that. Now, extreme values, where they occur, this is where they occur. Where did the extreme values occur are called critical points. I like to abbreviate them. So where can you find those max-mins? Well, if you have a closed interval, you could look at the endpoints, right? And then what else is true? Oh, well, I don't have this labeled. Well, I guess we do have. Okay, sure. There's. What else is true about your derivative? F prime is 0, or I can even extend this. And so where else could they occur? Where the derivative does not exist. I like those because those are easy to do algebraically. Finding the zeros is a little hard. Okay, so those are called your critical points. And you have to know that, and you have to know this word extreme value, because I can think of the problem on the exam. They'll say, how many extreme values are there? So you've got to know what that is. They're just saying, if you say extreme values, you're including all the max and all the mins. Yeah. Now, you don't have to really know this, but the stationary points is when the derivative is 0. Singular points are when the derivative does not exist. I can't remember any exam saying find stationary points or singular points. So it's more of a vocabulary. It's not that important. And the endpoints are just the points at the end of the interval. We're almost there to the theorem. And we're going to do a different problem than what's on here, because this one's kind of a tough one algebraically. Okay. How do you find extreme values? What conditions must be true? Okay. F of x must be continuous. That's good. What about the interval? It has to be close. There, yeah. And I don't know why I didn't do a very good job on this one, though. But I'm going to add a little bit. And I call this the max-min existence theorem. Okay, so I need a continuous function on a closed interval, and then I am guaranteed both a max and min will exist. Then f of x must have both. The max, both a max and a min. And we're talking absolute. I'll actually say that right there. I don't know if that matches or not. This is the assignment sheet. I'm going to get rid of it. Then I guarantee. This is a guarantee. Don't you like guarantees?
Guarantee that you'll have both.
You'll have both, right? And so the clue is they're going to tell you, either you're going to give you a nice, pretty function, you're going to say, oh yeah, it's continuous, or they're going to tell you f of x is continuous, and they'll give you a closed interval, and they'll say, find the maximum values. And you're going to remember this theorem. No, probably not, but okay. How do we find them? How do we find, and we're going to do a couple problems. Do we find the max and minimum value? Yes. There's no guarantee. Right. The question is, what if the function is not continuous? Or what if it has open intervals? There's no guarantee, but that doesn't mean you can't have. Like a parabola, y equals x squared. That has a minimum, doesn't it? Yeah, at x equals 0. Doesn't have a max. If you go negative infinity to infinity. How do we find the max and minimum value of the function? Now, if you're on an open interval, for you to find the absolute max and min, you really have to look at the graph. There's no other way. So, and there's a lot of problems in this section that don't, that are open intervals. So you're going to want your graphing calculator handy. Oh, we'll do it tomorrow. No, I got easier ones to do today, just to get the idea. How do we find maximum values? Okay, here are the steps, because some of you like steps, and I can do this in steps. First, well, you got to make sure the theorem applies. Then you set your derivative equal to 0. Yeah, I've got your room on the back. Set your derivative equal to 0, and you find where f prime is 0 and f prime is undefined. You find those places. And then this is easy. All you do is substitute these locations, these c values, and we'll call that, let c equal where they occur. We're going to do a problem. So you want to find out where the derivative is 0 or where the derivative is undefined. That's all you have to do. And then you evaluate, and I do it in a table, f of x at these critical points. Not the derivative, but the function. The critical points are where the extreme values occur. But they're going to ask you, what is the extreme value? And you just look at it. Okay, what's the biggest number? What's the smallest number? It's not that hard. The only calculus here is because you're going to do this without a calculator. The only derivative place of calculus is to look at your derivative. That's it. And we don't have any undefined examples today, but we will tomorrow. That one with the cube root of x as undefined. Some of it will be. Okay. On the back of your sheet, I've already written these up. Let's try a couple problems. F of x minus x squared plus 6 from 0 to 4. By the way, what does that look like? It's a parabola. What's special about this parabola? It's upside down. Oh, that works. So we know we have a maximum value, but where the minimum is, I don't know. And I really recommend you graph these. I think it'll help you to understand it better. So maybe we should get my calculator out and graph it. I mean, I know what it looks like, but I don't know exactly what it looks like. Now, when they give me the domain, that's a gift. 0 to 4, that is a gift. Most of the time you can do a zoom fit. It's close. Is it a continuous function? Yeah. So all you have to do is find your critical points. We'll clear that, and we'll clear that. And let's graph that. It was 4x minus x squared. We decided to try an easier one than a hard one to start. Now, I want my window to go from 0 to 4. I like zoom decimal, because then I get nice tracing numbers, so I'm just going to leave it. So if you zoom 4, you'll be okay. Whoops. Now, I'm glad this happened. Glad this happened. Because,
It doesn't.
no, there's no problem with my parabola. What's wrong with my graph?
Oh,
I'm zoomed in wrong. Okay, so I don't know how high to make it. So this is what I do. I go second table set, and I'm going to make that start at 0, and I'm going to count it by ones. And I'm just going to see how big I have to make it. Goes up to 10. It's probably my maximum value. So anyway, so we'll change our window to go. I want to change my domain now, though. I want 0 to 4, because this is exactly where I can look. Oh, that was weird. Okay. And we'll make this go up to 11. I want to be able to see it nicely. So, by the way, that does happen on the exam sometimes if you graph something and you write down what's on your calculator and you don't have the window the right size, you don't get the points for that graph. So you got to make sure. There it is. We can graphically look at this, but that won't count on the exam. Where's the maximum value? It looks like it occurs here. What it is, looks like it's about 10, but this is the C value. That's the max. What about the minimum? Is it going to be this one or that one? Well, you know what? I can't tell. Can you tell? So what we're going to do is we're going to evaluate it. But first, shall we find our critical points? Find our critical points. So f of x is equal to 4x minus x squared plus 6. So what am I going to do? Find what? F prime. So much easier, isn't it, than those other derivatives? What's this one? 4 minus 2x. Be really careful. I want to know where this is 0, but don't put 0 on this line because that's not right. 0 equals 4 minus 2x. Now, I like to solve. If I can solve by inspection, I do. Anybody tell me what x is? 2. You can go through the process of solving, but does everybody agree that 2 makes the sentence true? Yeah. X equals 2. Are there any other critical points?
yeah, we're.
Except, does this exist everywhere? The derivative? Yeah, it's nice, isn't it? Oh, yes, it's smooth. There's no sharp corners. And you know it's a parabola. Do you know there's no holes because it's a quadratic? It's a polynomial. Remember what a polynomial is? Polynomials are always continuous.
Stop.
That's why we like polynomials. Okay, I am going to make a chart. Because now to find the maximum value, you have to evaluate your critical points and your endpoints. So here's x, here's f of x, and we have where f prime is 0. You don't have to label it there, I'm just doing it. That's at 2, and then we have our endpoints. You don't have to label that, I'm just doing it. That's where, this is the where the max occurs. 1, 2, 3. No. It must have been a 2. Find out. And where are the endpoints on this? 0 and 4. Okay. So now, do I evaluate the derivative there or do I evaluate the function? I want to know when the function is its maximum. So you just evaluate the function. So what's f of 0? I do the easy ones first. That's 6. And f of 2 is going to be 4 times 2 minus 2 squared plus 6. 8 minus 4 plus 6. Where's that? That's a 10. And then I have to do f of 4, which is equal to 4 times 4 minus 4 squared plus 6, which makes me think of, a lot of people did 4 times 4 and said it was 8 on the test. Yeah, a lot did. Not your class as much as the other class. 16 minus 16 plus 6. Oh, that's 6. It's okay that you have a minimum occurring twice. It's the value. So what, and you have to be real clear about this. What is the maximum value of f of x? 10. That's the y coordinate. I'm going to write y there. Equals 10. They might ask, where does it occur? What's the minimum value of the function? I don't care. It could happen a million times. What's the minimum value? 6. That's the y value, again. And that's all there is. Because it was given to me. If I'm not given endpoints, then you can't do this theorem. They gave you the interval. Say it again. Oh, I just did f of 0. What's f of 0? 0 times 4 minus 0 squared plus 6. We found, I know, it's multi-step. This is what's hard about it. We found the maximum value of my function and the minimum.
By putting in the endpoint.
I evaluate the derivative, where the derivative is 0 or undefined, and the endpoints. Only calculus is to find out where they are. That was it. The rest is just evaluating your function at those candidates. Yeah.
There's like graph that goes like that, so like the endpoints are like flat.
Doesn't matter.
Which would be like
As long as it's as long. Yeah, it could.
Put your cube into the description.
No, this is f of x, not f prime. Function. I want the value of the function, not the value. The derivative is 0. Let's try another one. Yeah.
Take the derivative we found and put it in the original.
Into the function. Mm-hmm.
And then the endpoint you put it in the original function.
Right, and that's why I wrote down the steps here. You find where f prime is 0 or undefined, and you evaluate f of x. You evaluate this at these critical points.
It sounds where it's upstream.
It wasn't someplace. It doesn't have to be. Doesn't have to be. It doesn't have to be 0 either. Equals 0, undefined, and then the endpoints. Think of the absolute value function.
This is the derivative of the sign where it's like straight up and down.
Then it's not a function. Derivative's not going to exist here and at this one.
Well, the parabola gets pretty close. Probably not.
When the tangent line gets to be pretty big, but it never becomes vertical. Parabola always looks like this. It's close, but here's your vertical line. Okay? The other place would be vertical tangents, which that won't apply then. And discontinuities. Let's try another problem. There you go. Should we make the chart first? Let me see if I can. Let me try something. Well, I don't know how many critical points are there. Well, how many? Well, never mind. I'll do that. Oh, nice. Can I move this? Oh, nice. There we go. Okay. I kind of like to do the chart first. You don't have to do a chart on the exam. It's just easy. Here's x. Here's f of x. So I'm going to evaluate my function at my critical points. Well, I've got 2 right now. What's one of them? -3, and another one is 2. I will have to look for what now? Where f prime is the derivative going to be undefined? No, it's a nice cubic. We know what it looks like, don't we? Cubics look like this. John Travolta. John Travolta, right? Oh. We'll have to watch, what's the... Yeah.
Oh, like this.
Yeah, he's doing the dances, you know. Yeah. I don't know. Okay, what's the derivative of this? What's the derivative of this one? 3x squared.
Why do you have 4 bases?
I just made a bunch up. I didn't know how many there were. Actually, I do, but that's okay. I'm pretending I don't know how many there are. Plus 2x minus 8. And I want to see where this is what? These are endpoints. I want to see where this is what? Where the derivative is? 0. How are we going to do that? We need a little practice with this. What are we going to do to that thing? I suppose you could use quadratic formula. We're going to factor it. So it's 3. I mean, there's no choice. 3 and 1 are my only choices there. Yep. That's x. And then, because this is a minus sign, the signs have to be different. This is a difference sign. Signs are different. And 8 would be 1 times 8 and 2 times 4. As long as this middle number is not huge, it's usually going to be this one. And we try it. Should we just throw it in and see if it works? 2, 4. Did that work? That gives you negative 12x. That gives you 2x. Didn't work. So we're going to switch them. Factoring has to be done in pencil. I put plus there? Okay, so we're going to put the 4 here and the 2 there. And this is plus 4x, and this is minus 6x. So it almost works. Don't switch the numbers, but switch the sign. This is almost right. I get a negative 2x or a positive 2. So I'm going to make that minus, and I'm going to make this positive. Oh. Okay, ready? So then, now this is zero product property. Some of you guys like to put the 8 on the other side and do zero product property. Can't. The answer has to be 0 to allow you to do this. Sorry, I didn't mean the parentheses. Too much thinking? Okay. Can you guys do this? Is it 4/3 or 3/4? 4/3. Good. And the other one, and x equals negative 2. Okay, so I'm going to put these in. Are these in my interval? 4/3, is that between negative 3 and 2? Yes. And negative 2, that's also in there. If this hadn't been in the interval, we would have thrown it out. But it has to be inside there. So all you have to do now is what? Evaluate that function at those points. These are the endpoints. I'll highlight the endpoints. These are the endpoints, right? Doesn't matter. I could have put the endpoints last. And then these are the 2 candidates. So you're going to have to be careful. If it's an open interval, then you're going to have to look at the graph. You'll set the derivative equal to 0, but you're going to have to look at the picture. You as well. Okay, I'm really lazy today. I don't want to evaluate all that. So yeah, guess what? Shall we use our calculator? Yeah. Yes, it could be at the end point. These are candidates, just candidates. Well, how do we know? Guess what we got to do? We got to get our graphing calculator. We have to evaluate those, and I'm lazy today, so I'm going to use my calculator. Okay. Now here's how I'm going to do it. In y equal 1, I'm going to put in x cubed. We wanted to have a little practice factoring. If you want practice with the fractions, please do that. I always do that. It's x cubed. Then I have to arrow over. Because I don't look. Yeah, I messed up. Okay, there's y1. And I'm going to go to my home screen. And I'm just going to evaluate it at these points. So I'm going to do vars, because you don't have the new operating system. But I only have to do this once. I want y1 of negative 2. Let's do that one so I can see it. Negative 2. Enter. So that's 17. Whoops. There are my other values. Now, I'm really lazy today. I wasn't going to pull y1 up again. You could go second enter if you don't know this. And now all you have to do is go in and change that to negative 3. It's f of x notation. I'll do the 4/3. I'm doing negative 3 right now. I'm just evaluating. That's 11. Well, the 4/3 isn't going to be nice. You want to do 4/3 next?
No, let's teach it.
Oh, go in order, okay? And so let's do this as 2. I got to delete that and make this a 2. I'll show you in a second. We'll do it again. That was 1. Because I didn't look at the picture. I could look at the picture, but I haven't. Okay, now, how do I get y1? You go to vars, because you probably have an 83. and you go over to the y variables. If you have an 84, you can get the new operating system and get it an easier way to get it.
Oh, I have that one.
Okay, and we'll do 4/3. I'll show you that too.
You typed it, okay, so for Y1, you typed in the first equation, the other.
I put it in y1, yes. Negative 1.5. How many decimal places do I need? 3. So it's negative 518, negative 1.518. We don't care if you round or not. I just throw out the terms. And you're used to rounding, but both answers will get you credit. Okay. Okay, what's the maximum value? Okay, so that's and you have to be clear. Here's what you can do. You can write maximum value at x equals negative 2, but you have to make sure you make it clear to the reader that you know which is which. You can't just say it's 17. But if you want to you can't just give them the ordered pair either, by the way. Girls, listen up. You can't just say the order to be safe till you get all the information there. You have to read the question. You can't just say negative 2, comma 17. That won't get to the point. You have to say the maximum value is 17. Or if they're asking where, you have to say it occurs at x equals negative 2. So to be safe, say maximum value occurs at negative 2. You just cover your bases if you're not sure what the question is. It should be clear. We did what? We just look here and see the biggest and smallest value. What's the smallest value?
So we wrote down 10 and 6.
Because that was a different function. Those were the y values.
Yeah, I know. Why we write down the y value?
Because that's asking for that. The maximum value
He just said find the minimum.
is the value of the function. This is the where. The x's are the where. These are the values. That's. We won't have as much tomorrow. We'll go over tests tomorrow. Yes. But you're gonna. So really, what you're gonna try to do in the homework is look for the derivative being 0 or undefined. If you don't have endpoints, you have to look at the graph. You can still evaluate the function at those points. You're still gonna probably have to.
But that's what they're saying. So why do we write down 10 and 6?
This is the maximum. This is the minimum.
Yeah. So why didn't we write 2 and 4?
I could have said that, and I could have said at x equals 2. It depends on well, it depends on the question. At x equals 4 and 0. You get 2 places.
So we should have written that.
If I want to cover all my bases, because they might ask you, where does it occur? Or they might ask you, what is the value? You have to read the question carefully. You're in a stressful situation in that exam.
Let's write for these problems here.
This is what I'm asking. This is just giving more information that doesn't hurt me.
The next problem is worded exactly the same.
Right. This is the only answer. I just did both. So the question here is, what is the maximum value? It's 17. That's the answer to the question. I'm saying that they might say, find the maximum value, or they might say, where is the maximum value? To cover your bases, give them both. Because you're in a stressful situation, you know what I mean? You're going to be in a time test, you're going to, oh my God, what do I give, X's or Y's? Just do both. Sure. I don't think anybody will be here. Oh, sorry, wrong thing. No, yeah, I help you.